In his biography of the famous philosopher Ludwig Wittgenstein, Norman Malcolm reports, Wittgenstein said that he sometimes had a certain experience which could best be described by saying that when I have it, I wonder at the existence of the world. I am then inclined to use such phrases as, how extraordinary that anything should exist, or how extraordinary that the world should exist. This mystery, which according to Aristotle lay at the very root of philosophy, is one which thoughtful persons cannot avoid. Derek Parfit, a contemporary philosopher, for example, agrees no question is more sublime than why there is a universe, why there is anything rather than nothing. This question led the great German polymath Gottfried Wilhelm Leibniz to posit the existence of a necessary being, which carries within itself the sufficient reason for its existence, and which constitutes the sufficient reason for the existence of everything else in the world. Leibniz identified this being as God. Naturalists, on the other hand, have typically claimed that the space-time universe itself is necessary in its existence. That is to say, eternal, uncaused, incorruptible, and indestructible. Thus, David Hume, for example, queried, why may not the material universe be the necessarily existent being? Indeed, how can anything that exists from eternity have a cause, since that relation implies a priority in time and a beginning of existence? There's no warrant for going beyond the universe to posit a supernatural ground of its existence. As Bertrand Russell put it so succinctly in his BBC radio debate with Frederick Copleston, the universe is just there, and that's all. It was thus the presumed eternality of the universe that allowed naturalistic minds to rest comfortably in the face of the mystery of existence. This feeling of equanimity was first disturbed when in 1917 Albert Einstein made a cosmological application of his newly discovered gravitational theory, the general theory of relativity. In so doing, he assumed that the universe is homogeneous and isotropic, and that it exists in a steady state, with a constant mean mass density and a constant curvature of space. To his chagrin, however, he found that general relativity would not permit such a model of the universe, unless he introduced into his gravitational field equations a certain fudge factor, lambda, in order to counterbalance the gravitational effect of matter, and so ensure a static universe. But Einstein's universe was balanced on a razor's edge, and the least perturbation, even the transport of matter from one part of the universe to another, would upset the balance and cause the universe either to implode or to expand. By taking this feature of Einstein's model seriously, the Russian mathematician Alexander Friedmann and the Belgian astronomer Georges Lemaitre were able to formulate independently in the 1920s solutions to the field equations which predicted an expanding universe. In 1929, the American astronomer Edwin Hubble showed that the red shift in the optical spectra of light from distant galaxies was a common feature of all measured galaxies and was proportional to their distance from us. This red shift, first observed by Vesto Slipher in 1926, was taken to be a Doppler effect indicative of the recessional motion of the light sources in the line of sight. Incredibly, what Hubble had discovered was the expansion of the universe predicted by Friedmann and Lemaitre on the basis of Einstein's general theory of relativity. It was a veritable turning point in the history of science. Of all the great predictions that science has ever made over the centuries, exclaims physicist John Wheeler, was there ever one greater than this, to predict, and predict correctly, and predict against all expectation, a phenomenon so fantastic as the expansion of the universe. According to the Friedmann-Lamaitre model, as time proceeds, the distances separating galaxies become greater. It's important to understand that as a theory based in the general theory of relativity, the model does not describe the expansion of the material content of the universe into a pre-existing empty Newtonian space, but rather the expansion of space itself. The ideal particles of the cosmological fluid, which is constituted by the matter and energy of the universe, are actually conceived to be at rest with respect to space, but to recede progressively from one another as space itself expands or stretches, just as buttons glued to the surface of a balloon would recede from one another as the balloon is inflated. As the universe expands, it becomes less and less dense. This has the astonishing implication that as one reverses the expansion and extrapolates back in time, the universe becomes progressively denser until one arrives at a state of infinite density at some point in the finite past. This state represents a singularity at which space-time curvature, along with temperature, pressure, and density, becomes infinite. It therefore constitutes an edge or boundary to space-time itself. P.C.W. Davies, a British physicist, comments, if we extrapolate this prediction to its extreme, we reach a point when all distances in the universe have shrunk to zero. An initial cosmological singularity therefore forms a past temporal extremity to the universe. We cannot continue physical reasoning or even the concept of space-time through such an extremity. For this reason, most cosmologists think of the initial singularity as the beginning of the universe. On this view, the Big Bang represents the creation event, the creation not only of all the matter and energy in the universe, but also of space-time itself. The term Big Bang, originally a derisive expression coined by Fred Hoyle to characterize the beginning of the universe predicted by the Friedmann-Lamaitre model, is thus potentially misleading, since the expansion cannot be visualized from the outside, there being no outside, just as there is no before with respect to the Big Bang. The standard Big Bang model, as the Friedmann-Lamaitre model came to be called, thus describes a universe which is not eternal in the past, but which came into being a finite time ago. Moreover, and this deserves underscoring, the origin it posits is an absolute origin ex nihilo, that is, out of nothing. For not only all matter and energy, but space and time themselves come into being at the initial cosmological singularity. As Barrow and Tipler emphasize, at the singularity, space and time came into existence. Literally nothing existed before the singularity. So if the universe originated at such a singularity, we would truly have a creation ex nihilo. Thus, we may graphically represent space-time as a cone. Space and time begin to exist at the initial cosmological singularity. On such a model, the universe originates ex nihilo in the sense that at the initial cosmological singularity, it is true that there is no earlier space-time point, or it is false that something existed prior to the singularity. Now, such a conclusion is profoundly disturbing for anyone who ponders it, for the question cannot be suppressed. Why does the universe exist instead of just nothing? Sir Arthur Eddington, contemplating the beginning of the universe, opined that the expansion of the universe was so preposterous and incredible that, quote, I feel almost an indignation that anyone should believe in it, except myself. He finally felt forced to conclude the beginning seems to present insuperable difficulties unless we agree to look on it as frankly supernatural. Standard Big Bang cosmogony thus presents a challenge to metaphysical naturalism, since, in the words of Quentin Smith, it belongs analytically to the concept of the cosmological singularity that it is not the effect of prior physical events. The definition of a singularity entails that it is impossible to extend the space-time manifold beyond the singularity. This rules out the idea that the singularity is an effect of some prior natural process, end quote. Smith recognizes that the question which then remains is whether the Big Bang might not be plausibly regarded as the result of a supernatural cause. Otherwise, one must say that the universe simply sprang into being uncaused out of absolutely nothing. Thus, in the words of one astrophysical team, the problem of the origin involves a certain metaphysical aspect which may be either appealing or revolting.